Compound Characterization – Introduction to Spectroscopy. Let's say I came to you and handed you this white powder and asked you to tell me what it was. How would you go about doing that? The process of identifying an unknown compound is what we call characterizing it. When we characterize a compound, we learn about its properties. For example, what you might do is melt this unknown powder and then see if that melting point matches the melting point of any known compounds. However, as you might imagine, there are many compounds in the world which have the same melting point, so that on its own is not enough to figure out what it is. Another tool you could use is what we call spectroscopy. Spectroscopy is useful because it analyzes compounds on the molecular level. There is no way for us to directly see what atoms make up a molecule and how those atoms are connected. What we can do, however, is indirectly observe the molecule. And how we do this is by seeing how the molecule interacts with various forms of energy. What do I mean by indirectly observe? Think about this analogy. Imagine you are in a hallway and the hallway has a corner. And around that corner is an object of some kind. You cannot see the object directly because the wall is in the way. However, if there is a mirror at the corner of the hallway, you can use that mirror to indirectly view the object. It's a similar idea here. We cannot view the molecule, but we can view the energy that the molecule is interacting with. A basic schematic of a spectroscopy experiment is shown here. You have some kind of energy source. Usually it is some form of light. We then take whatever energy we have selected, and we shoot that energy at a sample of the compound we are trying to characterize, such as the white powder on the previous slide. The energy interacts with the sample in some way, and then some energy is emitted. That emitted energy is analyzed via a detector of some kind. That detector then translates that information from the energy to give us data in some form, usually in what we call a spectrum. This spectrum organizes the information in a visual way that we can interpret. We then take that data, that spectrum, and we analyze it and we interpret it to come to a conclusion. Hopefully, the identity of the molecule. You will spend a significant amount of time in the early portions of this course interpreting various types of spectra. It is likely that you have not seen anything like these spectra before, but that is no reason to be worried. While these spectra may appear abstract to start with, all spectra observe certain rules, and you can use those rules to interpret them. You should treat interpreting spectra very much like diagnosing a medical or an engineering problem. In many cases, these types of problems are not directly observable, but you can use multiple pieces of information to identify the problem anyway. For example, let's say you are a doctor and a patient comes to you with some symptoms, a cough, a fever, something along those lines. You cannot look at the patient and see the bacteria or the virus causing the illness. The symptoms are an indirect way of observing the illness. However, the symptoms on their own are usually not enough to identify the illness. You might run some blood tests, and those blood tests come back and give you more information that is complementary to the symptoms you already knew about. You then take the information from the symptoms and the information you obtained from the blood tests, and it can come up with a diagnosis. In other words, that was a logic puzzle. You took the information available and you came to a conclusion. Spectroscopy is the same way. You do not memorize spectra. Instead, you will be exercising your critical thinking skills. In this course, you will be given several different types of spectra, and you will be asked to interpret them, to pull out information, and then using that information, make a conclusion of some kind, usually identifying an unknown molecule. Let's say we are trying to figure out what that white powder at the beginning of the webcast was. What are some questions we might ask to try and identify it? You might ask, what atoms make up this compound? Are there carbon atoms in there? Are there oxygen atoms in there? If there are oxygen atoms, how many oxygen atoms are there? In order to figure out what the molecule is, we have to know what our building blocks are. What do we have to put together? Once we know what building blocks we have, how are those building blocks connected? In other words, what type of functional groups are present? If we have oxygen atoms, are those oxygen atoms in alcohols? Are they in ethers? Are they in carbonyls? Things like that. Once we know what functional groups are present, how are those functional groups connected? How do we put the pieces together to come up with the final molecular structure? Each spectroscopic method you will learn about in this course will help answer one or more of these questions. The spectroscopic methods you will use in this course will be mass spectroscopy, infrared spectroscopy, and nuclear magnetic resonance spectroscopy. For now, all you need to be aware of is what spectroscopy is and why we use it. That brings us to the end of this webcast. To recap this webcast, we cannot directly observe molecular structures. What we can do, however, is use spectroscopy to indirectly view molecules. Spectroscopy allows us to characterize these molecules and learn something about their structure. By the end of the first few classes of Chem 233, you'll be able to take all of this information from different types of spectroscopy and determine the structure of an unknown molecule.